So I see now that I've chosen 3 examples in a row where the upper limit was infinity. It might have been good if I'd chosen one where the lower limit was negative infinity, but I think you'll be able to catch on to the idea. We're going to have to replace this upper limit with a variable and then try to evaluate the limit as that upper limit variable goes toward infinity. So I'm going to rewrite this guy. This is going to be the limit, the limit as b goes to infinity of the integral from 1 to b of x e to the negative x dx. Ooh, fun! It looks like integration by parts. I'm going to let u equal x. I'm going to let dv equal e to the negative x dx. My du is dx. And my v is going to be the antiderivative of e to the negative x, which is negative e to the negative x. So I'm still taking the limit. If you look at the way this problem is done, this is an example from your textbook. The way they do it in the textbook is they don't write that limit stuff yet. They replace the upper limit with b, they find an antiderivative first, and then at the end they take the limit. It's up to you. I guess I'm kind of old school where if I'm going to take a limit, I have to be taking the limit from the beginning. But I'm open-minded to you doing it the same way that your textbook does. It's going to be the limit as b goes to infinity of, there's going to be all kinds of crazy stuff happening in here, right? So the antiderivative of x e to the negative x is uv minus v du. So negative x e to the negative x, that's uv, minus the integral, whoops, hold on one second, just to clarify, this needs to get evaluated from 1 to b, minus the integral of v du, that's negative e to the negative x dx, and the limit. This is the limit as b goes to infinity of negative x e to the negative x, evaluated from 1 to b, minus minus, this is going to be plus. I need an antiderivative for e to the negative x. That's really minus e to the negative x, also evaluated from 1 to b. So I'm going to move the rest of this out of the way and start at the top of a clean whiteboard. So I hope you can see what I've done here. I took where I was at the bottom of the screen. I changed colors just so we would know that I was kind of starting over at the top. And I don't have any more integrals, so I just wrote one evaluation statement that I'm going to evaluate from 1 to b. This is my new problem. I'm going to take the limit as b goes to infinity of negative x e to the negative x minus e to the negative x, evaluated from 1 to b. So I'm going to erase the rest of this stuff. All right, so that's the limit as b goes to infinity of negative b e to the negative b minus e to the negative b minus negative 1 e to the negative 1 minus e to the negative 1. It's the limit as b goes to infinity. A couple ways to think about this. That's e to the negative b times negative b minus 1 minus, so I just factored that e to the negative b out. I just had a little instinct that that might be helpful. Might turn out not to be helpful. And then I'm going to have mine inside these brackets. Negative 1 e to the negative 1 is negative 1 over e minus 1 over e. This is the limit as b goes to infinity. Negative b minus 1 over e to the b minus, how about we make this plus? I'm going to change this to plus and change this to plus and plus. That looks like 2 over e. So again, I'm going to start at the top of the screen and change color, just so you know. Notice the second half, the part that comes after the plus sign, doesn't have any b's in it. When we think about all the way back to chapter 2, all the different ways you can break up limits, it's going to be the same as the limit as b goes to infinity. Negative b minus 1 over e to the b plus the limit as b goes to infinity of 2 over e is just 2 over e. This part's not going to change. If you try substituting infinity for b, you're going to get negative infinity over positive infinity. So feel free to use L'Hopital's rule here. It's going to be the same as the limit as b goes to infinity of what is the derivative of negative b minus 1? That's negative 1. The derivative of e to the b is e to the b. And now I can see as b gets very, very big, the denominator of that first fraction is going to get big, which is going to make negative 1 over e to a very big thing, very close to 0. And that ends up being the limit as b goes to infinity of negative 1 over e to the b is 0 plus the 2 over e that wasn't at all perturbed by b's. So I would say there you go, my final answer, 2 over e. So remember that the words we used, we said that if I rewrote my improper integral using a limit expression and I was able to evaluate that limit, I have now found my limit answer is the same as the value of that integral. So the integral, what was it? The integral from 1 to infinity of x e to the negative x dx converges, and it converges to 2 over e.